So we're basically trying to take Wyoming Powder River Basin coal and to convert this into a high-performance asphalt binder at about the same cost as a normal petroleum binder. But we're designing it in such a way that we're using renewable vegetable oil-based chemistries to convert coal into the binder material that we want. This is going to allow us to produce a potentially CO2 negative material that can store CO2 in the pavement. And so this has a lot of advantage over petroleum in the fact that petroleum asphalt in the US actually has a very high CO2 footprint. So traditionally petroleum asphalt is just from the distillation of crude oil, and it's a byproduct because the refinery is trying to make fuels and other products. And so there's a lot of variability and issues with that. For what we're doing, we're actually taking the coal and we are not just using it as a waste or byproduct. We're actually engineering in the properties we want through chemistry. And so with this bio-based solvents that we're using, we're making hybrid coal and bio-based binders. So Powder River Basin coal is a massive reserve. It's extremely huge. We could pave 900 years worth of domestic paving needs with that material. Because it is so large, so easy to get at, it has one of the lowest CO2 footprints for any material that we can get and use, and it's extremely cheap. So it's about $14 a ton right now. And so the process that we're doing to convert it into this hybrid bio-based coal type of binder, what this allows us to do is store this biogenic carbon content in the pavement. When we do that, then some of our calculations have shown that we could store basically 5 million vehicles worth of CO2 emissions a year in an asphalt pavement. So the material that we're making now is actually becoming a carbon sink to remove CO2 from the atmosphere.
My name is Trina Pfeiffer, and I am the director for the Center for Carbon Capture and Conversion at the School of Energy Resources at the University of Wyoming. And we are in collaboration with WRI working on the Coal to Asphalt project. And one of the things that we are doing is we are augmenting the work that they have done. They've done a lot of chemistry and a lot of batch distillation and batch reactor work. And what we're doing is we're taking that and we're making a continuous process out of it. And this right here is our pilot plant to do that. So, and the reason you want to do that is because if you batch systems you can't scale up, they're not economically viable. But since we want to commercialize this technology, we have to get engineering data on a commercial or for a continuous process so we can build the plant that we're doing in Gillette, which is a in-between commercialization or commercial plant and this pilot plant.